R&D is a critical function of any forward-looking organization. When it comes to insulated panels, not only are there so many factors that affect the capacity of the product, but also because of its eminent benefits, there are so many different applications that the product can be used for, all with different performance criteria. That's why a very significant aspect of the development process is testing and more testing. People usually don't realize how much effort and resources go into the development process. Some of the main tests that we are continually performing as part of the ongoing development of our products and also as part of maintaining our conformance to the latest Australian standards as they're introduced are related to fire, thermal, acoustic, weatherability and structural. Today we're going to look at our structural testing facility where all our structural tests are conducted. When it comes to structural properties, you do small-scale tests of the components to prove the concept during the development process, and when you have the final product, you need to do many large-scale testing for meaningful results at the required level of certainty, and in our case, these results are used for generating span tables. Just by way of example, to generate one set of span tables for one of our products, we will have to do around 15 to 20 non-cyclonic tests and perhaps another 10 cyclonic tests. This is a couple of months of testing alone, not to mention the planning efforts all the way to the analysis of the results and independent certification that follows. Around 8 years ago, we designed and fabricated our own test rig and obtained NATA accreditation to ensure quality and impartiality of the results for independent certification by external engineers. Over this period, the rig has been used full-time, fully dedicated to in-house testing and product development, performing hundreds of tests and giving us invaluable insight into the behaviour of our products. Test procedures to the relevant Australian standards, collection and recording of pressure and deflection values, and report generation are all fully automated. This not only ensures accuracy of our data, but also saves us an enormous amount of time, allowing us to do more and more tests. Today we're going to perform a few tests to demonstrate the structural benefit of insulated panel compared to single skin products. We're going to test Metecno span insulated roofing and compare it with a typical concealed fix single skin product, which would be considered for the similar commercial applications. First, we assemble the product. The cladding system consists of sheeting, fasteners and supporting members assembled together in a manner identical to the roof that the test specimen is intended to model. The product is on the rig and we're ready to go. To begin with, we look at the serviceability criteria under non-cyclonic conditions, assuming a maximum allowable deflection of span over 150. We're testing the insulated panel at double the span of the single skin product. Starting with a pressure of 1 kPa, we increase this incrementally and check the deflection. As we can see, the single skin product exceeds the serviceability deflection at 4.2 kPa, and the insulated panel at double the span doesn't deflect much, and in fact it doesn't reach the allowable deflection, even at the ultimate failure of 6.6 kPa. Next, we look at some cyclonic testing. Roofing products need to be tested to the low-high-low pressure sequence specified in NCC in order to be used in cyclonic applications. The purpose of this specification is to ensure the performance of the roofing system is adequate under cyclonic conditions. In other words, the cladding should not be detached from the framing or become windborne, which might cause damage to the surrounding areas or be a safety threat. In this case, Metecno span is double the span, but both are subject to the same cyclonic conditions. Here we're looking at the two products undergoing the same sequence. In this video, we won't show you the entire sequence, which takes several hours to complete. The test starts with sequence A, which is 4,500 cycles at the lowest pressure. Then the pressure is increased from 45 to 60% of design pressure, and the cladding undergoes another 600 cycles, and so on. We're now looking at the end of sequence C, which then moves to sequence D. At this point, the specimen is subject to the maximum pressure, which is held for 1 minute. After that, the pressure is reduced and we'll go through another 5,180 cycles. During the whole sequence, the test is monitored closely for any signs of failure, which may be due to fastener pull-out, pull-through, skin wrinkling due to bending failure, shear failure of the core, or joint failure, and so on. The single skin product experienced pull-through and rib buckling during sequence D while applying the maximum pressure. The insulated panel at double the span managed to withstand the entire cyclonic sequence. In conclusion, both products performed as expected and in line with the manufacturer's recommendations. This confirms that the greater expandability of insulated panel allows architects to design more dramatic spaces without compromising structural integrity, and the overall cost can be reduced by minimizing the amount of structural supports required.